I bet Trump's something like, oh, we heard everything. He's ours. Bag him.
Deported. Questions before this quiz. Questions on the packet. We wasted about 5 minutes, so that's probably at least one question I'm not going to be able to answer. All right, Michael.
17.
17. Watch closely because I'm going to go very, very quickly. Yeah, I'm probably going to have to reset this a bit. 17. They give us this picture. This is going to help us with today also. We got this triangle ADE. There's BC here. BC. They tell us this is 10. This is 40 degrees. Tyler's making sure he's watching closely because he wasn't here last time to learn all this stuff. Let's make sure he understands it. That's 32. How many triangles in this picture?
2.
2. And the very first thing you should do is split them off. What's the letters here?
A.
Ignore that. What letters here?
B, C.
Here. Here. Do we know this side in this triangle? Do we know this angle?
12.
Angle. We don't know the angle, do we? Do we know this side?
No.
This angle? No. This side?
No.
This angle?
40.
So I'm just filling in the stuff we know. Do we know this angle?
40.
40. Do we know this side? We know part of it, right?
X plus 10.
What would you do with this? If we wanted to find the whole length here, what do we do, Mark?
X plus 10.
X plus 10. We just add those two together, not multiply, add them together to get the whole length. So X plus 10.
10x.
Do we know this angle?
No.
Do we know this angle?
Yeah, 32.
32. That's a 3. Do we know this side?
You missed the side.
21.
Oh, we do know this side, don't we?
21.
21. Do we know this side?
No.
That's a 21. Ignore that extra mark that went up through there. All right? So that's all the stuff that we know. Part A, what's part A ask us?
Find the scale factor.
Scale factor. How do you find the scale factor of any shape? I guarantee the first problem on the quiz that you're getting ready to take says find the scale factor. First thing you do to find the scale factor,
Take 2 sides from that.
2 sides that you know and match them up and set up a ratio. All right? So pick me a side in this triangle and a side in this triangle where we know both the numbers for 'em.
BC, which is 12, and DE, which is 21.
So K is 12 over what?
21.
Do we just leave it that way?
No.
No, we reduce it down. Grab your calculator, and to reduce it down, you just use the ABC button on it. 12, ABC button, 21.
4 over 7.
What is it?
4 over 7.
4 over 7. Anybody else agree with that? What other answer would I accept on that one? 7 over 4 if it was flipped over going the other way. Now, sometimes both answers aren't acceptable. If you know you're getting bigger, then which one of these two should it be? 7 over 4. If you know you're getting smaller, which one should it be? 4 sevenths. Part B, what's part B ask us to do?
Find the value of that.
Find the value of x. To do that, we're going to have to set up a proportion. Be ready to solve this proportion for me because I'm not solving them up here because I don't have space to do all this problem. What's the first ratio going to be?
Either
4 over 7. You could just use that scale factor, or you could go back to the 12 over 21. You could use either one of those. So if I wanted to do 4 over 7, just because those are small numbers. Then I want to pick out, so I picked out this side compared to that side. Now what's the second thing I want to pick out? What am I going to put first on top over there? The 10. We want this. And what's going to go on bottom? What's it match up to? X plus 10. What did I tell you last time when you had something like x plus 10?
Parentheses.
Put parentheses around it. We cross multiply. Here you just write down 4 times x plus 10 equals, what do I get when I cross multiply the other way? 70. Solve that.
X equals 74.
What's the first thing you do?
Distribute.
Distribute. Should be solving it right there on your paper so you understand this. Don't just listen to Mark. Mark's not gonna take all your quizzes for everybody.
7.5.
7.5, anybody agree with that? So that's part B. What part C asks us to do? Find angle ABC. ABC, that's this angle right here. How are we gonna do that? Then we told us one angle.
Sends.
Pass that up to 180.
If we look over here, they tell us two angles. Can we find this angle? How would you find this angle?
180 minus 72.
180 minus those two add together. What's that give you? 108. If these two triangles are similar, what do you know about angle B and angle D right there? They're congruent. So what's this angle right here, ABC? 108. Corresponding angles, the angles that match up have to be the same. Do the sides have to be the same? No, they're proportional. Angles are the same, angles are congruent, sides are proportional. What D ask us?
Perimeter of ABC is about 42.4 units. Find the perimeter of ADE.
This one, we gotta use, I gave you this proportion last time. You gotta know these two proportions. That one, that one. All you're gonna do is fill in the spots. What do I put right here? What's that tell me to put right there? The perimeter of the first shape. What do I put here? Perimeter of the second shape. What do I put here? Side of the first, side of the second. Just plug into those four spots. Do I know the perimeter of the first shape? I think they told it to us, didn't they? Michael just read it. 42 point what? 4. Sorry, I can't write. Do we know the perimeter of the second shape? That's what we're looking for, so I'm gonna let it be P. Do we know a side in the first shape? Yeah, we've set up like 6 different things over there with the side. Give me a side in the first shape. 12. Do we know a side in the second shape? What did it match up to? 21. How do we solve this? Cross multiply and solve. I'm not gonna do the cross multiplying and solving for you. You can do that yourself. Figure it out. What is it? Perimeter of the other shape.
42.4.
Well, we already got 42.4.
84.8 units.
What is it? I heard 84 something. Huh?
84.8 units.
84.8. Anybody else get that? 'Cause that don't sound right to me.
74.
That's what Mark said.
74.2.
I got 24.2.
Okay, you're done.
24.2. Now Michael knows, because he's going to look up here, because we talked about this during intervention. If this one's 42 and it matches up with the 12, and you just told me this one's 24, is that going to work?
My calculator is
It's
correct.
74.2.
74.2. Anybody else agree with that one? I've heard that like 3 times now.
Yeah.
That's what it is.
Yeah.
74.2.
That's what I got.
I think I found
Michael, I
my
think
mistake.
what part of your problem when you're using your calculator, you got to hit that equals button.
I do.
So, all right. I thought that might have been the problem. Because when you cross multiply here, multiply, hit equals, then hit divided by whatever.
Yeah.
I'm thinking that maybe sometimes you miss a button and you don't hit that, because then it's going to give you a different answer. What did he ask us for?
The area of triangle ABC is about 71.75 square units. Find the area of triangle ADE.
So this triangle right here, watch closely on this one. Lane, you watching?
Yeah.
Because this is the hardest one, and I know it's on the quiz, and this is the one you're probably going to have the most trouble with.
That's a square.
This formula, area over area, side over side, but what do we have to do to both the sides?
You have to
We got to
square the
square
sides.
them. So we got this area. What's the area of this other triangle over here? We don't know, so I'm going to put an A in there, stand for area. Side from the first triangle, give me a side from the first triangle. We've done this like 10 times. 12, thank you. Give me a side that it matches up to in the second triangle. 21. What do I got to make sure I remember to do with the area one? You got to square each of those. This is going to stay the same, so 71.75 over A equals, what are you going to do over here?
144.
144 on top. 441 on bottom. Once I do that squaring for both of those, now what am I gonna do? Cross multiply and solve it, just like every other problem. So do that, cross multiply and solve it for me.
Is it 219.7?
219.7, anybody else agree with that?
Yep.
What's our units? Did they give us any units?
Square units?
So units squared,
No, square.
units squared, square units. I know I didn't write it down because I don't feel like it. F, what's the last thing? I'm not writing this one down because I'm out of space.
Segment BC parallel to segment DE, explain your reasoning.
They're asking us if that's parallel to that. Daniel's gonna look at it and go, yeah, it's parallel.
It's not.
We need to know for sure. What'd you tell me about this angle? We never did write in. What'd you tell me about that angle right there? It was 32, right? And this angle was 108. We never wrote both those in. So what's this angle right here? 32. We had a theorem earlier this year, and this is part of what we're going to do today, so a little foreshadowing. If I know that those two angles are congruent, let's think back to earlier this year. I had two lines like this. What was that line called?
Transversal.
Transversal, good. If I know this angle is congruent to that angle, what do I know about those two lines?
Corresponding angles are congruent, so they have to be parallel lines.
So these lines have to be parallel because if corresponding angles are congruent, then the lines must be parallel. We did that earlier this year, right? And then we're going to do a whole bunch of that today. So if these corresponding angles are congruent, remember corresponding is the ones where if you take the two lines, smash them together, they're the ones that lay over top of each other. So are these two parallel?
Yeah.
Yes. And we write yes, and our reason is because if corresponding angles are congruent, then lines are parallel. I know Trina thinks that she's not ever going to see that again, but what I tell you on the last test, you had to explain a bunch of stuff, right? Guess what's going to happen on the test when we take it, the next one?
Explain it.
You got to explain, and that's one of the things you'd have to explain. Give me another problem. 16. It's the area one, and that's the one I told you was the hard one, right? Figure A has an area of 4,928 square feet, and one of its sides is length 88 feet. Figure B has an area of 77 square feet, and they want us to find the side that matches up. Am I going to use this? This? Yeah, the one that deals with area. So what goes here? Area of the first shape. Do we know the area of the first shape?
4,928.
4,928. Do we know the area of the second shape?
77.
77. Before I go much farther, because this is going to help Michael out, look at these two numbers and how they compare. This here's a pretty small number compared to that. So when we get over here, this should be a big number compared to a small number, right? That's what should happen. So when we get our answer, we can make sure it makes sense. Do we know the length of one of the sides in the first shape?
Yep, 88.
88. What do I have to do to that 88? Square it. You got to make sure when we're dealing with area, that's got to be squared and this has to be squared. Do we know the other side? So what are we going to make it? X. Now, it's not just supposed to be X. What's it supposed to be? X squared. I'm not going to put that squared on there for a minute. All right? Because I'm hoping this helps Dakota see that. Because Dakota, I can tell as soon as I put something on this, like this on there, I don't know how to do that. But when I leave that 2 off, he doesn't have any trouble. He remembers all that from algebra. All right?
X equals 120.
What do we do to this 88 first? Square it. Somebody do that for me.
7,744.
So we got that over 77 equals 7,700 and what? 44 over X. Now what do I do?
Multiply 7,744 by 72.
Cross multiply, get 4928X. What's on the other side? When you cross multiply this way.
5
Just tell me the numbers.
596,288.
Anybody else agree with that?
Yep.
Quentin gave out on me already. That was too big a number for his calculator. Apparently, he didn't want to waste his batteries with that big a number. Now what do we do? Divide.
121.
4928. Divide both sides by 4928. These cancel out. You're left with what on the left-hand side? X. What's on the other side? 121.
And luckily,
Now,
that thing.
Dakota. We did all the same steps that we do, and we got this, right? Now watch. All right, so now I stuck that 2 back in there. Is that going to change what we've done up to that point? Everything's exactly the same. All right, you do all the same steps. Now, are we quite finished? No, now you've got to do what, Mark?
You got to take the square root of that number,
That's
which
all I
that
need
is
to
the
know.
perfect. That's a perfect square number. So
11.
it is 11.
The inverse or the opposite of squaring something is taking the square root. So I take the square root of this. What's the square root of x squared? What times what gives you x squared? X. And if I take the square root of this side, what do I got to do to the other side?
Square root.
Take the square root. What's the square root of 121?
11.
Now let's go back over here. If I take out this x squared right here and I put 11 in there. Big number, quite a bit smaller number. Do you think those two match up the same?
Yeah.
Yeah, they're pretty big compared to 11, right? So does it make sense for the side in that second shape to be 11? Yeah. Give me a number that wouldn't make sense for a side to be in that second shape.
9,999.
89. Why not 89? Because it's bigger than 88, and the top number, or I'm sorry, the bottom number shouldn't be bigger than the top number. So if you get an answer like 89, you probably messed up somewhere. All right? Clean sheet of paper.
You said if we get an 80% or higher.
Nope, go away. Clean sheet of paper. Clean sheet of paper. No, not really. Clean sheet of paper. Clean sheet of paper. I'm going to throw it in the trash because you got to, well, you should be focusing on something else right now. Five problems. You got about 5 minutes. When you get done with it, you're going to lay it right here on this desk. $138, that means about 143. Real quick, if I don't have your quiz, put it up here, otherwise it's 0 now. These two triangles are similar to each other. How do we find the scale factor? Pick two sides. Give me two sides. 12 and 6. What's that reduced to? No, 12 over 6 doesn't reduce to 1/2.
Or 2 over 1.
2 over 1. What's the other answer I would have accepted though?
2 over 2.
1 over 2. Either one of those would have been all right. Find the length of RT. To do that, we're going to set up a proportion. Remember, when you're setting up this proportion, what would this first fraction right here be? We just did it up here. 12 over 6, or we could use 2 over 1. Which one's probably the easier? Probably use that. Probably easier. We use 2 over 1. RT right here is what we're looking for. What goes on top here? 8. What goes on bottom? X. We solved that. Anybody remember what RT was? 4?
Yep.
Sounds right. So we now know this side's 4. Find the measure of angle R. How are we going to find the measure of this angle when they didn't tell us any other angles in this triangle?
First 2 angles up there.
So if that angle's 62, what's this? If this angle's 82, what's this? Add them up, subtract from 180, what do you come up with?
100. Yeah.
144, is that my answer?
No, 36.
What's my answer? What's the answer?
36.
36 degrees. Find the perimeter of QRT when I set up the proportion for perimeter. What goes on top right here?
Perimeter 1.
Perimeter of 1. What is it? So what?
30.
30?
Yep.
What goes on bottom here?
X.
Now I'm going to use P. What goes on top here? 12. What goes on bottom here?
6.
6. Just two of the sides, right?
Yep.
Cross multiply and solve. What'd you get for the perimeter? 15. Anybody agree with that?
Yep.
Area. What's going to be different when I set up the area one?
You're gonna wear it. Yep.
You got to square the sides. What goes on top here? 40 on bottom. X. I'm going to use A. Top 12 squared. Bottom 6 squared. When you do all this, I got 40 over A equals, what's 12 squared? 144. 6 squared.
36.
Then you cross multiply. What did you get when you cross multiply?
A.
20? 10?
There you go.
10 what? Centimeters squared. Does it make sense for the area of this one to be 10 if that area of that one's 40? Forgot to put the units squared, or you forgot to square it?
Is that paper you gave me today, is that homework?
Yep.
Okay.
Go ahead, start copying this down.
I think I can go. I forget about number 1.
Scale factor, what about this?
Well, when you got a like 2 over 1 or 1 over 2, my calculator gave me straight up.
2.
Oh. Because I was saying, I didn't probably teach that.
But the bad thing with that is you gotta know that your calculator doesn't give you anything unless you do what? Tell it stuff, right?
Right.
So you gotta be able to read your calculator and know what it's telling. So anytime you have a whole number, what's the number that's on the bottom?
One plug. I got the plug.
Proving triangles are similar. About 10 more seconds, I'll turn this slide. Be able to prove triangles are similar to each other. Be able to use triangles, similar triangles to find parts of the triangle. So find missing sides or missing angles. What do you know about angles in similar triangles? They're the same. They're congruent. What do you know about sides? They're P word. Proportional. Angles are congruent. Sides are proportional. Angles congruent. Sides proportional. Write this down, draw this. There's 3 different ways to prove triangles are similar. First, before we start writing this down, give me the ways that we learned to prove triangles were congruent to each other. SSS, I heard.
Angle side angle.
Angle side angle.
Side angle side.
Side angle side.
Angle side side.
Make sure you don't give me the Michael theorem. Doesn't work.
That's the code.
Oh, is it Dakota?
Yeah.
Angle, angle, side. Sorry, I didn't hear you. Somebody said the Dakota theorem, and that's the one I heard. They were drowning you out. Those are ways to prove that triangles were congruent. The 3 things we're going to learn today are ways to prove that these triangles are similar to each other, not congruent. So don't get them mixed up.
What's the double A mean?
What does the double A mean? Angle, angle. So now, and this is the one, notice I put a bunch of asterisks on this. This is the one we're going to use 99% of the time. Because the other 2 are harder and more drawn out and we don't want to use them. So this is the one that we use most of the time to prove that 2 triangles are similar to each other. Angle, angle. So what's angle, angle tell you? What do you got to do to prove the triangles are similar?
2 angles have to be congruent.
Pair of angles then another pair of angles. That's it. So if I give you two triangles like these two that I have drawn up here, and I tell you this angle is congruent to that angle, then I tell you this angle is congruent to this angle, what do you know about those two triangles then? They have to be similar. That's all you need is two pairs of angles. Do you have to make sure they match up? There's no way for them not to match up. If I draw two triangles, and I tell you this angle is congruent to that angle, then I tell you this angle is congruent to that angle, is there any way that those angles aren't somehow going to match up to each other? Not in a triangle. In a four-sided figure, five-sided figure, six-sided figure, yeah, they might not match up. But in a three-sided figure, if you know two in this one, two are congruent to two in this one, there's always some way that those triangles are going to turn and match up. What do we know about this third pair of angles right here?
They're congruent.
They're congruent. We had a theorem earlier this year called the third angle theorem. Remember that? If two angles in this triangle are congruent to two angles in this triangle, what do you know about the third pair of angles? They got to be congruent. Somebody read this bottom thing here to me.
Triangle BLA is similar to CPR. Laser.
That's the one that we're going to use the most. We're going to use it on these three examples. You don't have to write these down. You can write them down if you want, but that's up to you. I look at these, how many triangles in this first picture? You're going to see these pictures over and over and over again for the rest of this chapter. 2. Not 3. Why not 3? What's the other shape that everybody's looking at like it's a triangle? Probably a trapezoid. Alright, it's not a triangle. So I know that this angle is congruent to this angle. So I got a pair of angles. Is that enough to say the two triangles are similar? No, I need something else. What else do I know?
BE is congruent to CD. Not congruent, no, it's parallel. What am I saying?
And what might help you? What I said earlier. You see a picture like this, what should I do? Split them off. Draw the two triangles separately. So this is A, B, E. This is C here. That's an A. That's a D. I already know this angle is congruent to this angle. That's the ones they told us. What do I know about angle A and angle A? It's congruent. We're going to have a vocab test next week. And you're going to need to know this next thing that I'm getting ready to say. How do I know angle A is congruent to angle A? Reflexive property. Anything equals itself. That angle A in the small triangle is exactly the same angle as the angle in the big triangle. Is that enough to say the two triangles are similar?
Yep.
Yeah. Now, we're going to name the triangles. Name this first triangle for me. Say it louder. ABE. Tabitha took the easy one because it doesn't matter how you name the first triangle. It makes no difference. Doesn't matter how you name the second triangle. Yeah, they got to match up. What's the A match up to? A. What's the B match up to? C. What's the E match up to? That's our similarity statement. What's these arrows tell us in this one? Parallel. So FG is parallel to KJ. As soon as I have that and I draw this in, what's that line called?
Transversal.
Transversal.
G is automatically congruent to J.
Angle G is congruent to angle J. Why are those two angles congruent? What kind of angles are they? They're alternate interior. We used that a whole bunch a month or two ago, right? Same thing here, right? What do we know about these two angles? Alternate interior also. I don't like those two angles though. What do we know about these two angles?
Vertical angles are always congruent.
Vertical angles are always congruent. Got pair of angles, pair of angles. Is that enough to say the two triangles are similar? Yeah. Now here's where you got to be careful. Name the top triangle for me. FGH. Does it? Oops. That's a G. FGH. Does it matter how you name the first one? No. Now here's where you got to match it up. What's the F in this triangle match up to in the other one?
KJH.
K. Does this just flip over? No. What do you have to do to this triangle?
Rotation of 180
degrees.
Gotta rotate it around. So K matches up to the F. What's the G match up to? The J. And what's the H match up to? The H. This one, how many triangles in this picture?
3.
It's 3. So this time we're going to name 3 triangles that are similar. Now, before we do this, because I guarantee you if we just take it right now the way it is, you're going to mess it all up. Alright? What I would do with this is I would find the angles that I'm missing. Like, what do I know about this angle right here?
It's a right
It's
angle.
a right angle, so let's put that in there. What can I figure out about this angle right here?
It's 32 degrees.
How'd you come up with 32, Mark?
Add those two.
Add, actually,
Could I-
complementary.
Could have added
angle,
these two, subtracted from 180 for that triangle, right? Or
Subtract.
that's a right angle, we could have just subtracted from 90. Either way, is it going to give you the same answer?
Yep.
So it's 32 degrees right there. How about this angle down here?
32 degrees.
32 degrees also. Now, the reason I'm doing that is because if you don't do this, you're going to be lost when you try to match these things up. When I separate these triangles, and I draw this first one, and the 32 degree angle is pointing up in the air, and the 58 degree angle is here, and the right angle's right there, I want the other ones to match up to that, so it makes it easy on me. Alright? So what do I have to do to this triangle to get it to match up to that one? Flip it up, right? So it's going to look something like that. What's this angle up here? 32. What's this angle? That's 90. Now the biggest one, this one here, it's going to go something like this. Flipped up in the air like that. What's this angle up here going to be? 32, 58, 90. Now let's put some letters on these so we can name them. What's this letter right here in this small triangle?
L,
L. How about this letter?
M.
M. How about this letter? Here's where you got to be careful. What's this letter? And the second, the middle shape, or the middle size. What is it? P. What's this letter? M. This letter? What's this letter? In the big triangle.
L.
L. This one?
P.
P. This one?
And
Oh, wait.
Is that right?
No, that's something else. Because if that's the big triangle, like the overall triangle, that one you have to put 90 at the top.
We don't want 9. We wanted to turn it so that the 32's at the top.
No, okay, you said there's 3 triangles.
Uh-huh.
And there's 3 up there. And that big triangle.
It's this whole thing right here.
Yeah, and that angle, the 2 angles are 90. The P. No,
So-
I'm confused.
P is the right angle, right? Did we mark P as the right angle? Yeah.
I know I did.
And that's why I want them, are you going to be confused if you don't do that? Yeah, you're going to be lost. Michael's going to be lost anyway because he's looking at me like, I'll find a trick to do that.
I'll find some.
Triangle, name this triangle for me. PLN. Is it going to be easier to match them up now? Yeah, what's the P in this triangle match up to in this second triangle? N. What's the L match up to? P. And what's the M match up to? M.
That worked there.
How about the third one? N, LP, everybody agree with that? Tell me, in the small triangle, the side LM, if we were setting up a proportion matching up sides, the side LM would have to go over what side in the big triangle? LP. Does everybody see how you can use the names? LM is right here in the big triangle. LP is right there. Same spots. That way you can match them up maybe a little easier. Write this down. Don't worry, there's a bunch more after this.
Yeah.
9. Somebody read this right here to me.
Side, side, side.
Close.
Side, 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 similar.
Why do I put that little symbol there and why does it matter?
Because
because we have one that is side
congruence theorem.
We had the congruent one. We gotta make sure we don't get those theorems confused. This theorem is to show that the triangles are similar. The other one was to show that the triangles were congruent. I think the first problem on the homework deals with this first one here. Again, we're not gonna use these very often. The ones that we're gonna use that angle the most. Why would we use angle more than these two? It's easier. It's that simple, it's easier. Why do you want to prove 3 things when you could just go with 2? Now, does that mean you can only prove 2 every time?
No.
No, sometimes you have to use these other 2 because that's the information you're getting.
You want to draw the pictures?
Yeah, you probably should.
So I see that we put in another 3, 4, 5 triangle.
Nope. 2 of them.
As in exactly 3, 4, 5. As in no other measurements above 3, 4, 5.
Nope, they're both called 3, 4, 5 triangles.
Yeah.
Yeah.
I'm talking about the measurements being 3 units, 4 units, and 5 units.
Nope, this one's a 3, 4, 5 triangle too.
Yeah, but its units are 6.
It's a 3, 4, 5 triangle then.
I know that.
Part of that family.
He knows everything.
It's just like saying you're right now trying to argue that you're not an Armstrong, but we know that that's wrong. This is a 3, 4, 5 family.
What's 3, 4, 5 triangle?
We're gonna talk about next chapter.
Oh.
I know what it is.
Of course you are.
He does.
Hit us later.
Actually, yes I do. Mr. Harrison trained us right.
On this,
Hey, dog.
side, side.
You trained us.
Back to this. If we're going to use this to prove that these 2 triangles are similar to each other, all we do is do the ratios of all 3 pairs of sides. Give me a side in the first triangle.
6 and 3.
6 matches up to
3.
3 in the second triangle. Give me another pair of sides.
8 and 4.
10 and 5, and then what?
8 and 4.
If these 2 triangles are similar to each other, what should happen is all 3 of those ratios should be equal to each other.
The proportion is 2
So
over
what's this reduced to?
2 over 1.
2 over 1. What's this reduced
2
to?
over 1.
2 over 1. What's this reduced
2
to?
over 1.
So what's that tell us about these 2 triangles?
Proportion.
They are
Similar.
similar. Now that doesn't help us a whole lot because a lot of times what are we looking for when we're dealing with triangles? Length of a side. What length of the side are we going to look for in this one? None of them because we know them all. But it does sort of help us because what do you know about angle A? It's the same as angle D, and we could do the angles. But we usually don't, we're more involved with the sides than the angles. Side angle side similarity theorem. Anybody remember what included means?
It's the angle that's straight in between both sides.
So if I have that side right there, GJ, and I have that side right there, JH, which angle is the included angle? J, it's this angle. Well, what do I know about angle J right there? It's vertical. It's the same as that other angle down there, right? And you can't name it angle J. I shouldn't have done that. We should have used 3 letters, but those 2 angles have to be congruent. That's the included angle, that's the A right there. Then what you're gonna do with the sides that surround it, set up a proportion just like we did here, only with 2 pairs. Give me a side in the top triangle. 10. Now here's where you gotta be careful, because Tyler's looking at it and he's going, well, that 10 matches up to that 9 because you just flip it over. That could be. But what else could you do with this triangle to get it to match up?
Rotate.
Could rotate it around. So you gotta be careful of that and make sure you know which way you're going. In this case, which way should I do it? Should I just flip it or rotate it?
I rotate.
Rotate it. So what's the 10 gonna match up to?
9, 15.
Then what's the other 2 sides?
6, 9.
What's 10 over 15 reduced to? 2/3. What's 6 over 9 reduced to? Are those the same? What's that tell us about these 2 triangles? They're similar to each other. So these are the other 2 ways. Again, we're going to use angle to prove 2 triangles are similar. A whole lot more than those. Write this down. Have you ever seen this list before? Yeah, it used to be written on the board over here for about the first 2 months of the school year.
I memorized this in 5th grade.
Write this down. Probably when you get to this first example right here, I'm probably going to start. So you might just write down one example as we go through each one. Does that make sense? So when Quentin gets to right here, he can probably stop and then we'll work the problem. Then he's going to write that down, we'll work it. Then he's going to write that down, we'll work it. Write this down, we'll work it, so on, so on, so on. Does that make sense?
Hey, Mr. Emerson,
Yes, Lane.
I got a joke for you. Please no. No, I'm doing it. Okay, so what kind of shoes does a spy wear? Sneakers.
Ah,
Wow.
That was so bad.
what kind of shoes is Michael wearing?
Like, that's why it's considered one.
Girls.
That's a very big pun, I don't like it.
Dang. It took you 5 minutes to explain that.
Not even funny.
It was
That's
an
actually good.
exaggeration.
That's a redneck dad for you.
Alright, on the first one. You should have learned this stuff in algebra. If you didn't, can't help that, but you're going to learn it now. But we're going to do it very, very quickly. So Daniel says, well, I didn't learn it in algebra. I've never seen this before in my life. Don't care. You're going to learn it now. Either you learn it now, or when we get to next chapter, you'll be completely and totally lost.
Or that's how I am
Right. So the first thing we're going to do, we got this. This symbol right here. Number 1, it's not called a square root symbol. Square root is the actual operation. Teresa's looking at me like you're crazy. It is too a square root. The symbol itself, that check mark box, is called a radical. That's the symbol. Just like this dot. That dot's called a what? A dot. But we in math, what's the operation that goes along with that? Multiplication. That's not called multiplication. That's called a dot. Alright? But we know when we see that dot to do multiplication. Same thing here. This is called a radical, the symbol itself. But we know to take the square root when we see that symbol. What we're going to do with this, you're not going to grab your calculator, and some of you are going to be real upset with me on the next test. Because on the next test, you grab your calculator and you do this. Square root 75. And Tyler writes down that. Square root, I hit the wrong button, 75. And Tyler writes down that answer right there. And I mark it wrong. Because I want exact answers. And that answer that calculator is giving you isn't exact. Because what are you going to have to do to it?
Or round.
Round. So this is what we're going to do. You take this radical and you look through this set of perfect square numbers and you try to find a perfect square number that'll divide evenly into that number that's under the radical. First of all, is 75 in this list?
No.
No, so it's not gonna come out even.
Go.
Give me a number that is in this list that'll divide evenly into 75.
64.
25.
Oh wait. Oh.
So what you're gonna do is you're gonna split this apart and you're gonna make it the square root of 25 times, how many 25s are there in 75?
3.
Notice both those are still under the radical. This is sort of like reducing a fraction. What is the square root of 25?
5.
So that comes out of the radical. That's no longer under the radical because the square root of 25 is 5, the whole number. Can we take the square root of 3?
No.
No, we just leave it that way. That's our answer. 5 times the square root of 3. Just leave it that way. That's your answer, and that's an exact answer. Not the answer that Tyler's getting ready to tell us. What's the answer? It's on your calculator.
8.6602254038.
That's not the answer we want because it's no longer exact because we had to round it off. This is an exact answer.
So find a number that can divide it, the closest number.
Find a number that will divide into it off of that list.
Alright.
So this one, what's it going to break into?
Probably 9.
9
Yeah, well, 9.
times what? 2.
Square root of 2.
What is the square root of 9? So that comes out of the radical. What's still in the radical? So what's our answer? 3 times the square root of 2.
That's
3 radical 2. 3 times the square root of 2. That's an exact answer, and that's a simplified answer. Just like when I give you a fraction like this, your 3rd grade teacher gave you a fraction like that, did they accept that as your answer? No, they told you you had to do what to it? Reduce it, simplify it. That's the same thing we're doing here with these radicals, simplifying it.
What if we can't find a number on there that divides?
I will come, maybe, so, give me some number.
502.
That's something.
So we got 502, square root of 502.
0.5.
What are you gonna do? Take your calculator and start seeing if any of these will divide evenly into it, right?
Right.
So do it. Will 4 go into it?
Yep, I know it wants this.
Will 9 go into it?
Nope.
Will 16 go into it?
Nope.
Now, some little hints here because I'm tired of calling out numbers already. If 4 won't go into a number, will 16?
No.
So is there any reason, once you check 4, is there any reason to check 16? No. 9 is divisible by 3. 3 is like a key number in all of math, right? You can tell if 9 will go into a number by doing this, adding up all the digits. What's 5 plus 0 plus 2? 7. Will 9 divide into 7 even? Guess what 9 won't do in 502 then?
49.
It won't divide even.
Maybe.
25.
No.
Because it'd have to be like 100, 200, 150, something like that, right? 36.
No.
49. It didn't work? 64. Same idea here with 4. If 4 won't go to it, is 64 going to go into it? No. 81.
Same idea.
No.
Same idea as with 9. If 9 won't go into it, 81 won't go into it. 100. No. 121.
No.
144.
That one.
169. 196. 225. 256.
For sure not. That would be 512.
That's too big, right? 289, 324, 361, 400. We could keep going and do 21 squared and 22 squared, but once you get to 400, it's not going to go in there. It's not going to work, right? The only thing that could be true is that could be a perfect square number that's not on our list. Somebody take the square root of 502. See if it comes out even.
That is, no, it's not, it's 2, it's like.
So what we do to answer Lane's question, if it's this number and it won't break down like we did these two, guess what your answer is?
That's
That right there. That's an
Trick
exact
question.
answer. On this next one, the reason I put this next one on there, is so that we can look at these two things. On this, what a lot of people want to do is they want to just take this 2 and divide 12 by 2 and then get that answer. It doesn't work. Radical numbers and regular numbers can't be multiplied or divided together. They're not the same kind of numbers, so they can't be put together. So you cannot just take 12 divided by 2 and get 6. Doesn't work. Down here, it's going to be different. So on this one, just look at the top, square root of 12. Is there a perfect square number that'll go into 12? 4 times what?
3.
What is the square root of 4?
2.
So that comes out of the radical. What's still in the radical?
3.
Square root of 3.
Square root of 3.
So it'd be the square root of 3.
Now, here, we couldn't divide these two, but guess what we can do with these two regular numbers? Divide them. Guess what's going to happen with them? Turn to 1. They cancel out. So all that simplifies down to just what? Square root of 3.
But that's not right.
That's right.
3 times
You're not squaring it, you're taking the square root.
3. So the square root of 3 is
1 point something.
okay.
We don't want that answer though, we want an exact answer.
Speed it, yeah.
This one, what's different about this one?
Rationalize.
That's true, but what's different from the last one? They both got square roots. These we can divide. What's 12 divided by 2? What'd I forget? The square root. That's our answer.
That is.
So you just divide this.
Just divide them. Now sometimes might this break down like these up here we're breaking down? Yeah, but 6. 4 go into 6 evenly? 9 go into 6 evenly?
No, that's
Too big, isn't it? So it won't simplify. How about this one? What do you come up with? Square root of 9. We're not going to leave it that way though.
It's 3.
Square root of 9 is 3 is a regular number. Please be careful, because I guarantee you on the next test, I'll have somebody and guess what they'll put around this 3? The square root. Once you've taken the square root, don't put it back on there. Alright? Just like when I'm doing this. 2 plus 3. What's 2 plus 3?
5.
Do I put a plus after the 5, put it back in there? No, once you've done that plus operation, it's done. Don't put it back in there. Once you've taken the square root, don't put it back in there. This one's a little different. Will 3 divide into 14? No. So watch closely on this one, because this is actually what rationalizing is. If you're taking the ACT test or the SAT test, sometimes, if it's a multiple choice question, that square root of 75 without being reduced down, they may write your answer that way. Alright? Other times, they'll write your answer that way. Are those two the same numbers? Yeah. Other times, they'll give you this. That number that Tyler gave us a little while ago. Alright? All 3 of those are the same number, same answer, just written different ways. They might also write it as a fraction. This one, most books don't do this anymore. Most books don't do what's called rationalizing. But all rationalizing is you cannot have a square root in the denominator of a fraction. Alright? It's not a good form to leave a square root in there. So what we do, and this is just a process. I tried to explain this to one of my class the other day and they just could not understand, well, why are you doing that? I'm telling you, it's a process. This is just the way you do it. Alright? It's got to be done this way. To get rid of this radical out of the denominator, we multiply the bottom by whatever that radical is. So in this case, we multiply the bottom by square root of 3. If you multiply the bottom by the square root of 3, guess what you got to multiply the top by? Square root of 3. Whatever you do to the top or the bottom, you got to do to both. Somebody help me out. On bottom,
9.
square root of 9. On top,
42.
square root of 42. Sorry, my writing's not very good, so I hope you're listening. Square root of 42 over square root of 9. What do you know about the square root of 9? It's 3. Square root of 42. Can we break it down like we did the others? Maybe. Will 4 go into 42
Yeah.
evenly?
No.
9 go into 42 evenly? 16,
No.
25,
No.
36,
No.
49.
Too big.
Too big. So it just stays as the square root of 42. So Lane, that sort of answered your question from the 502, right? Square root of 42, we just leave it that way because it won't simplify down.
So if we can't find a different answer, then the question itself is our answer.
Yeah. How about this one? What do you think you do here? Multiply. What do you get?
Square root of 100.
Square root of 100.
10.
What is the square root of 100?
10.
10. So all that simplified down to just the regular number 10. How about this one?
That simplifies.
Square root of what? 18. Hey, we just did that. What's that simplify down to? 3 times the square root of 2. You'll see that a lot where you use the same thing over and over again. So if Michael remembers, hey, I just did the square root of 18 and simplified it down. Does he have to do all the work again? No, just write down the answer again. What do you think you do on this last one?
Well, you have to like reverse.
Looks a little different, doesn't it?
Take 3 times 4, get 12.
Slow down for a second now, Mark. So you take 3 times 4, because they're both regular numbers, right? Well, what is 3 times 4?
12.
12. What do you think you're going to do with the radicals? Times them also, just like you did over here. What's 5 times 15? 75. Are we just going to leave it that way? 12 times the square root of 75? What do we know about 75?
Good afternoon, National.
It simplifies
Have
down.
a few announcements for you today.
So now we have this.
There will be an art club meeting for all members during intervention on Monday. We will discuss activities for the remainder of the year.
Are we going to leave it that way?
Mandatory meeting. So if
What do you think
cannot
you
make
do
it,
with this 12 and 5 out in here?
Alexander prior
Multiplying.
to
What is 12
intervention.
times 5?
Want to say good luck to the wrestling
60
team as they
times
travel
the square root
to
of-
Sydney Lehman today and tomorrow for their
That's our
wrestling
answer.
tournament.
60 times
Also wanna say
radical 3.
good luck to the boys basketball players as they travel to their tournament.
Should have learned a lot of that last year in algebra. You ever see that before, Tyler? Never.
Also want to remind you that we have plays
even in Mr.
tonight
Harrison's
and
class.
tomorrow. Pocahontas. Doors
Yeah.
open at 6:30 on both nights. Tickets are
Your
$6.
assignment's laying up here. Grab one from each pile. These 2 worksheets.
That concludes the announcements for today. So have a great day, great weekend.